Hi, my name is Sarang Tripathi with SingleStore's Cloud Solutions Engineering team. Today I'm going to show you a demo of SingleStoreDB. But before I do that, let's just do a quick overview of SingleStore in case you're not familiar with us. SingleStore is the single database for modern data-intensive applications. We power several Fortune 500 companies such as Uber, Sony, Comcast, Hulu, and Kellogg's. We also power 5 of the top 10 banks, as well as hundreds of SaaS companies building disruptive modern applications in their spaces. So SingleStore powers data-intensive apps, but what does that mean? Well, data-intensive application is one that embodies one or more of the following characteristics. Requires very fast ingest of data, low latency queries, or high concurrency in their application. So how do we do that at SingleStore? So SingleStore combines both transactional as well as analytical workloads in one place. This is a problem that was historically solved with several different databases in one place. And to add to that, SingleStore also supports relational, geospatial, key value, JSON, time series, and several more types of data. Now, when you look at this, traditionally, these types of problems, again, were solved with several different data type specific database or workload specific databases. And with SingleStore's universal storage, which is a patented technology, we're able to bring all of these transactional, analytical, and multi-model data and workloads into one place to serve those data intensive applications. So today you're going to see a demo of a real-time marketing and analytics. So we're going to take a fictional telco with millions of subscribers and serve them targeted ads and offers to customers in real time. We're going to target those ads based on demographics, geolocation, purchase history, and much more. And then what we're going to end up doing is evaluating 80 million ad serving opportunities in real time and serve 30 to 50,000 ads and offers in real time to their cell phones. So this is a real-time digital marketing app where we're sending out notifications of offers that are based on matching algorithms and complex customer segmentation on real-time and batch data. All these notifications are going out to customers in real time throughout New York City. And on our right side here, we can see how many offers we have, how many subscribers, segments, and how fast those algorithms are actually running. The segmentation is running in under 300 milliseconds here, matching running very quickly as well. And all the while, we're adding more and more location and geospatial data to our database in real time, and the map is reacting to it. We can also zoom out and see across the entire city how our notifications are going and how the segmentation and matching analyses are running as well. So you're going to see several different data types today, and these data types will be both real-time as well as batch. So you'll see purchase history of customers. So what did they purchase in the past that we can base our decisions on today? You'll see subscribers data, which is going to come in more as batch. You'll also see real-time streaming subscriber location, which will be geospatial data and geospatial functions on top of that data. You'll see offers, web history, notifications, and it's really important to note that all of this data is going to be of different types. You'll have relational, geospatial, JSON, and time series data, all that's real-time and batch in nature. So you see some of the tables here on the side that we're going to pull in, and some of the volumes. We're going to stream this data in real time and in batch to show you this use case today. So here's a bit about the logical flow of the demo. So we'll have all those data sources we just discussed. We're going to pipe them through Amazon S3 through SingleStore pipelines. This is a unique differentiator for SingleStore, where we're bringing in data through a highly parallel fashion. I'll show you how to build a pipeline in a second. Now, highly parallel fashion to ingest real-time and batch data from S3 and then merge that data up with segments that we have and offers that we have within the database. What we'll then do is under 500 milliseconds, do a matching algorithm that takes real-time data, batch data, matches it up against segments that we've created, creates offers for customers, and then pushes them out as notifications. We'll assess 80 million notification opportunities and send out 5 million plus notifications to end user cell phones in this demo. So you'll see real-time data ingest, matching, algorithms being run, and then ultimately data being pushed down to downstream systems in this demo today. So let's dive into the demo. So we're going to start in SingleStore's portal. So once you sign up for your $500 in free credits, you're going to get a screen that looks just like this. Try SingleStore Managed Service with your credits. I'm going to say create database cluster, and I'm just going to name it demo cluster. And then at this point, since SingleStore is deployable on AWS, GCP, or Azure, you'll get the option to choose which one you want. So I'm going to select AWS. I will then also select US East Virginia, and then you'll get your compute tiers. So this is another unique differentiator of SingleStore in that we separate storage and compute. So here you're just selecting your compute size, which on the right side of the screen here, you can see you can select several different types of compute clusters ranging from very small to very large. Once you get into the demo, you'll also see that you can scale up just with one click. So I can scale up from the S00 to the S0 at any time. But let's just start with an S00 today. Separately down here, you'll see storage. So we selected our compute cluster. Now storage is unlimited within SingleStore. So once you spin up your compute and you start loading data in, you will have an unlimited amount of data to be able to be stored within SingleStore, because in addition to local disk within SingleStore, we're backed by object storage. So you can continue overflowing that data, and you're just charged at the standard cloud provider rates. So we'll hit next, and I'm just going to create a password here. And then SingleStore recognizes my IP, so I will just do an allow list from my current IP and keep going to say create cluster. So now you'll see that my cluster is deploying. I'll just walk you through the interface a bit here. So I have my cluster type, which I can change from development to production or whatever I'd like. The size, which will populate here. And then once this finishes deploying, I can just hit edit and scale that up whenever I'd like. Shows the region, when it was created. I can change my password at any time, etc. I will eventually be able to see which databases I have, the firewall list, and change that at any time. You can also change that through an API. And I have more security information here and much more access to the cluster within this portal user interface. So now let's jump into another cluster that we have that's actually going to host that digital marketing demo that I told you about. All right, so now we're at my marketing demo cluster, and I've got quite a bit of SQL here that I'm going to go through and run. But let's actually just go through and do this from the context of an application so it can really understand what it's like to interact with SingleStore through an app. So here you see our real-time digital marketing interface. The first thing that we have to do, as I'm sure you're familiar with, is connect to the database from the application. We're going to do that with the host and port, username, and password. I've got my green check mark here, which shows that I've connected to SingleStore successfully, and the next step is to create my schema. I've not yet created the database, so I need to name the database and then say set up schema. And then when I say create database, it'll create the database as well as all of these tables here that I've specified. So while it's doing that, let's actually jump in to the real-time and batch data and the tables that we're going to be storing it in today. So the first table that we have is customer segments, and we're actually going to store this in our Rowstore within SingleStore. So within SingleStore, we have 3 tiers of storage. The first tier of storage is an in-memory Rowstore. So we store data here, like reference data that needs to be accessed very quickly, or our most hot data that we want to be accessed very fast within our application. So our segments data is going to have a segment ID, and then valid interval, filter kind, filter value, things like that we're going to use to reference very fast within our application. The next, something that might be a little bit more familiar to you, is the purchases table, all that historical data that we're going to be bringing in around our customers. And this data is going to be stored in column store, which is tier 2 of our 3-tiered storage within SingleStore. So this is our purchases table, which has city ID, subscriber ID, timestamp, vendor. And you'll notice here on lines 27 and 28, we have also specified a shard key and a sort key. Let me tell you a little bit about that. So shard key in SingleStore is going to determine how the data is distributed across the database. And sort key is going to determine within the column store how we're sorting our column store segments, which makes it really easy to access data in filters and joins and things like that. Now you'll see here also I've noted our third tier of storage, and that's our object storage. If you remember, I told you earlier that SingleStore separates storage and compute. So we have our in-memory row store, we have our disk-based column store, but then we also, if we exceed disk, have object storage. So you never run out of storage within SingleStore because anything that exceeds disk will flush to object storage and still be accessible by your application at any time. Also have one more table here that's also a column store table called our locations table. And this is a table that, again, is multi-model in nature. We have relational data types that, that are common, like integers, and we also have time series data. We also have geospatial data within this because we're looking at different locations that our customers are in. You can see I have a shard key and a sort key in this table as well also. So it looks like all the schemas are set up. And now it's time to ingest that data. So within SingleStore, we can ingest data using pipelines, and I'll show you how to do that in a second. And pipelines is not limited to just S3, which you'll see today. You can bring in data through real-time sources like Kafka, and other batch sources like Google Cloud Storage, Azure Blob Storage, HDFS, and many others. So let's give it a try. Here, I'm just going to select Create Pipelines, and while it does that, I'm going to actually show you how to create a pipeline. So creating a pipeline is as simple as 5 lines of SQL to do large-scale parallel ingest, in this case from S3. So we just identify which S3 endpoint we want to get data from, and we tell it that the data is in Parquet format, and we identify those columns, and we're off to the races. We'll do the same thing for our locations table here, and as we can see here within our UI, we're already bringing in data. So this real-time graph within our application here, that's going to show us how fast we're bringing in data using our SingleStore pipelines. So you can see now already we have 17 million locations, 19 million locations, 10.5 million requests, and 2.5 million purchases from that historical data from our customers. I can also go in and benchmark here. I can do some simple benchmark queries on how fast I'm getting data in from certain sources. And you can see the locations table on a small cluster is bringing in data at 466,000 rows per second. And that's a small cluster. So now let's just jump in to look at all of the zones that we're going to place offers in. So each offer has a max bid price, activation zone, the list of segments that are going to be dedicated to that offer. And what you can see here on the right is a reactive map that's going to leverage all that geospatial data and geospatial functions within SingleStore to power that map. Each polygon within this is going to represent the activation zone of an offer that we're going to use. And there's 1,600 offers in our database today. So next thing we're going to do, as mentioned, each offer includes a list of different segments associated to that offer. A segment could mean somebody that bought a coffee in the last day or visited this specific grocery store in the last week or the last month. And we could evaluate all the segments dynamically here, but what we're going to do is run an algorithm to match subscribers to segments because the database is that fast and able to actually run these algorithms very quickly for us. So let's go ahead and just say match subscribers to segments. Matching those subscribers to segments, 37 million rows against 561 segments, producing 3 million plus memberships of subscribers to those segments is taking just 143 milliseconds in SingleStore. So this is the power of being able to run transactions and analytics in one place on multi-model data, something that would take several different other database engines to do in a combined fashion is all being done within one database, within SingleStore here. Now to the fun part, we're going to do matching. So now that we've assigned subscribers to certain segments, we want to send these offers out to them and generate these notifications. So let's go ahead and do that. So now you can see in real time, we're generating these notifications that are going to go out all across New York City. And I can generate these periodically using a routine. I can generate them manually by clicking within my applications. But as you can see here, we're evaluating segments, evaluating notification opportunities, and actually sending out these notifications within 760 milliseconds. So now let's put it all together and look at a couple other dashboards. So what you're seeing here is a geospatial dashboard of all these notifications going out now. And on the side, you're seeing analytical metrics such as how many offers we have, 400, in one city. We're looking at 100,000 subscribers at the current moment across 561 segments. And the segmentation is taking just 183 milliseconds, sometimes less than that, to do the segmentation. The matching is taking under 100 milliseconds on this growing amount of data, all the way end to end, from getting that data in, getting those transactions in, doing the analytics, running the algorithm, and then pushing those notifications out is all happening in several hundred milliseconds. Now we can jump into an analytical dashboard that probably looks pretty familiar to some of these modern apps that you're out there running yourselves. So again, we have the number of offers, number of subscribers, and notifications. But now we have a dashboard that we can sort, that we can slice and dice and really make decisions on. Again, coming back to that most important key metric of conversion rate. We're able to see in real time what our conversion rate of customers is based on requests, and our conversion rate of purchases as well. If I'd like to go in and sort, I can do that, and you can see how quickly my dashboard is sorting for me. Now I can sort by conversion rate to see which customer has the highest conversion rate in my entire data. This is simply something you cannot do with other databases. Bringing in those transactions, doing the real-time analytics, and then having a reactive dashboard that shows you all that information at your fingertips in one place. But there's one more key thing to being able to do analytics on real-time data. And that's the ad hoc nature. You must have developers, data engineers, analysts out there that are curious to just use the SQL editor and check out the data. So let's hop back into our customer portal where we can do some of those ad hoc queries. So I'm just going to start by doing a simple vendor analysis. I'm going to just say I want to join my purchases data with my locations data on subscriber ID and look at a specific vendor. And you can see here, I've run the query a couple times, and under a second, a few times in a row, I'm able to perform this join and look at city ID, subscriber ID, look at some time series data, as well as a geospatial column that's going to show you the specific locations where this vendor has been, and really take a look at that vendor analysis. But your data engineers and analysts may be more interested in a more complex analysis, like a ranking analysis. So here what we're going to do is a total conversions over notifications, which is going to give us a conversion rate. We're going to do a complex query to look at different offers, customers, notifications, and how all of that information comes together, and how we can drive the best conversion rates within our business. So wow, you can see in 161 milliseconds, I've gotten a ranking of customer, notification zone, which is a polygon, a geographic type of data, total notifications, total conversions, conversion rank, ranked. So now I'm looking at my customers, where they converted the most in New York City, all under 200 milliseconds. So now that you've seen the power of SingleStore through the demo, let's just discuss a bit why customers choose SingleStore for their modern applications. The first is a 20 to 100x performance boost, eliminating performance bottlenecks on those single node sort of Gen 1 databases out there like MySQL, any of the RDS databases like Postgres or Aurora, and other cloud databases. The next is lowering costs and complexity due to multiple data engines. We talked a lot today about how some of these transactions and analytics and different data types require so many different databases and data engines. Well, SingleStore can solve that problem through consolidation of those databases to bring your workload into one place and really eliminate the need for cobbling together Redis and Mongo and Snowflake and Druid all for your application. The last is that need for real-time analytics, the ability, if you recall that dashboard, to bring in real-time data experiences into your application through a distributed SQL database that supports both transactions and analytics without the need for massive data movement. So in summary, what you saw today was a data-intensive application with SingleStore, and we can help you power your data-intensive applications too, help you get that blazing fast data ingest that you saw in the demo today, low latency queries, and limitless concurrency across all of your customers for today and in the future, truly to bring it together operations, analytics, all on multi-model data in one place for all of your data intensive workloads. And we would love for you to try out the demo that we showed you today on GitHub. It's available for you to test and try with your $500 in free credits. There's a link here as well for you to try that. So we're really excited to have you try out SingleStore. Thank you.